It's 6:30 a.m. on the banks of the St. Johns River in Clay County, Florida. September mornings are usually quiet here as we slowly start to cool down after a long, hot summer. However, something is different this morning.
Oh, oh my God. Even more?
What you just saw is pretty unusual for Northeast Florida, so what exactly is making the sky light up so early today? Usually when we see thunderstorms in our part of Florida, they happen during the daytime. That may sound obvious on paper, but in places like the Midwest, the Plains, or even parts of the Deep South like Mississippi or Alabama, intense thunderstorms often do occur overnight. However, when it comes to Florida, things are a little different. A lot of our convection happens outside of organized weather systems, such as fronts, low pressure systems, or troughs. Rather, much of our warm season storms are heavily driven by daytime heating. This is twofold, both in how direct heating of the land can cause popcorn or air mass thunderstorms, but it's also the heating difference between the land and the sea that drives Florida's sea breeze. For today's case study, we're going to take a look back at a storm I observed on the St. Johns River early on the morning of September 4th, 2024. It was a gorgeous lightning show, and quite the intense thunderstorm in general for it occurring so early in the morning. I want to look back at this storm and use it as a tool to help understand how and why nocturnal thunderstorms, though being relatively rare around Northeast Florida, can still occur around here under the right circumstances. The synoptic setup across our region on September 4th, 2024 is one that is fairly common on the first coast this time of year. Starting on September 3rd, 2024, a frontal boundary began to stall out over Florida and much of the Gulf Coast region. By the morning of the 4th, the boundary was parked right over the first coast. With the boundary stuck overhead, showers and occasional thunderstorm activity would occur for much of the next week. The boundary helps provide an area of convergence, or where air meets and rises. This creates lift in the atmosphere, which helps spur convection. The stalled boundary also pulls moisture along it, and especially in front of it, which also helps spawn showers and storms. Behind the boundary, persistent wind flow ranging from northeasterly to easterly helps direct storms towards the Atlantic coastline. This onshore flow helps create a zone of convergence along the coastline, which once again enhances lift. During onshore flow regimes, heavy downpours with occasional embedded thunderstorms often hammer the coastal counties, with inland coverage being a lot more spotty. These downpours can also be extremely slow moving, which can lead to flash flooding. For example, there was a public weather station report on the 4th that stated that over 4 inches of rain had fallen over the course of 1 hour. That's the kind of thing that can happen when you combine tropical levels of atmospheric moisture with a frontal boundary. Getting into some of the atmospheric parameters, things were fairly standard for this time of year. Using this 8 a.m. mesoscale parameter table from the SBC, surface base CAPE was at 1682 joules per kilogram, while mixed layer CAPE was at 1240 joules per kilogram. This is solid instability for September, especially for it being early in the morning. Shear values were seasonably low, with only around 10 knots of effective shear. This means storms would stay relatively messy and unorganized, unlikely to become severe or to sustain themselves for very long. Lapse rates weren't very steep either, with low levels being at 4.6 degrees Celsius per kilometer and mid levels being at 5.7 degrees Celsius per kilometer. With decent instability in place, lapse rates being relatively meager was not an issue. Though this storm was memorable to me for the lightning, the real star of the show, impact-wise that morning, was torrential flooding rainfall. Precipitable water values range from 2.1 to 2.3 inches area-wide, with areas near the coast getting near 2.4 inches. As a reminder, precipitable water, or PWAT for short, is a measure of atmospheric moisture. PWAT values at or above 2.0 are considered to be tropical, and when storms tap into this deep moisture, they often dump torrential rainfall. Another important factor to this case study, and Florida convection in general, is the concept of the warm cloud layer. The warm cloud layer is the depth inside the cloud from the cloud base up to the freezing level. This is important for rainfall, as all liquid water below the freezing level will remain just that, liquid. I do want to note though that water doesn't immediately freeze above the freezing level. Sometimes you have droplets that stay liquid below the normal freezing point. These droplets are known as supercooled water. That note aside though, when you have a deep warm cloud layer, this lets raindrops grow larger through collision before they ever freeze, leading to a more consistent and intense heavy rain. Looking back at the mesoscale table, the mixed layer lifted condensation level, which is just weather jargon for where the cloud base is expected to form, is 511 meters, or about 1,676 feet off the ground. The freezing level for the day, which is the point in the atmosphere that reaches freezing, was 16,414 feet off the ground. Simply subtracting 1,676 from 16,414 gets us a warm cloud layer measurement of 14,738 feet, which is roughly 4.5 kilometers or 2.8 miles tall. Think about that. 2.8 vertical miles of a storm where only liquid water droplets can form. It's no wonder these storms can drop so much rain in such a short time. To quickly summarize the synoptic setup, a stalled frontal boundary overhead combined with onshore flow to help organize local areas of convergence. Along these areas, the atmosphere managed to tap into sufficient instability and plenty of atmospheric moisture to produce multiple messy but torrential downpours and thunderstorms across our region early on the morning of September 4th, 2024. Severe weather was not expected to be a threat per the SPC outlook and the NWS Jacksonville morning forecast discussion. The possibility of gusty downbursts with winds peaking at 40 to 50 miles per hour was mentioned, but otherwise the primary threats were those that you would see inside most thunderstorms: torrential rainfall rates and lightning. While not severe weather, a wind advisory was issued for a few of the coastal counties in Florida and Georgia. Primary threats here would be occasional wind gusts of 40 miles per hour. This is a fairly common occurrence in the fall and wintertime here, especially when we have frontal passages or onshore flow regimes. The encounter I had with the storm we saw on September 4th was not exactly what I would call deliberate. The storm occurred at around 6:30 in the morning, which means I would usually either be at work or asleep, but as luck would have it on that day, the atmosphere was primed for storms well before I even woke up. Looking over at the radar, we start at around 3 a.m. with multiple storm clusters already inland, including one over Clay and one over Duval County. A weak-looking cell begins to move onshore near Palm Valley, seemingly producing some outflow. This line of outflow would attempt to bubble up a new, stronger cell for around an hour and a half, while the initial storm dissolved. Until about 5 a.m., the storm stayed mostly stationary, with precipitation building generally north and northwesterly. You may notice this was actually against the main atmospheric flow. This backbuilding behavior was likely caused by the aforementioned outflow boundary and the new cell's own outflow. The atmospheric flow was also relatively weak, only being around 10 knots. When there's weak atmospheric flow, storms can occasionally build in unusual directions off their outflow or other local boundaries, which cause convergence. The cell looked to expand between 5 to 6 a.m., with a wider area of hefty downpours being the trade-off for a tighter, more organized core. Switching over to echo tops, you can watch the storm try to build for hours, but it really doesn't get very far. We're looking for a nice core of dark greens with some yellow on top. This indicates cloud tops between 40 to 50,000 feet. This threshold is finally hit just after 6 a.m. and is accompanied by a burst of lightning. On the Echo Tops radar, you may not be able to see much yellow, and that's because the storm is too close to the local radar for it to scan all the way up. The radar perceives the storm as topped off, even though Echo Tops were likely exceeding 50,000 feet briefly. As you can see, there was a little bit of yellow, but you can't see the full core. As to why the storm intensified like this after 3 hours of being relatively lackluster lightning-wise, my best guess is additional convergence along the St. Johns River or possibly outflow from earlier cells giving the storm a new boost. Swapping back over to normal reflectivity radar, the cell really begins to get its act together between 6 and 6:30 a.m. You can notice a more organized area of heavy convection in the deep reds along the St. Johns and Duval County border, northeast of Fruit Cove. The storm seems to hit peak intensity around 6:30 before quickly weakening towards sunrise. At around 6:20 that morning, I was driving out of Fleming Island when I noticed lightning flashing over the tops of pine trees. I continued to drive southward off the island when I saw more intense flashes coming from the north and to my northeast. I pulled off at a local marina on the St. Johns River and I got to recording as fast as I could. Little did I know that I was about to have one of the best lightning chases I've had so far in the past 2.5 years of storm chasing. The lightning was so good I couldn't help but pop off like Jim Cantori when I saw some of them.
Oh, yes! Yeah! Oh my god, I hope it got that. That was so fucking bright. Oh, holy shit! Yo! Oh my god, that was awesome! Hey! Get it back. Whoa! Ooh. Whoa! I think I'm gonna go ahead and get moving now, but before I go, I do want to get one more shot. You can actually see the storm now that there's light. You can see the sun rising a little. So, it was a very nice experience being out there early in the morning and getting to see storms.
After the lightning fizzled out, I decided to head home for the day. Some more scattered showers and thunderstorms would occur later on, but nothing nearly as notable as what had happened on the morning of September 4th. Thankfully, no severe weather events were reported around the First Coast, despite multiple SBSs being issued overnight for near severe strength wind gusts, and even the possibility of water spouts or land spouts. However, this does not mean that our region got off scot-free that day. As mentioned earlier, flooding rainfall was the big weather impact of the day. In terms of just the raw number of alerts, there were 14 flood advisories throughout the day, along with 4 flood warnings in the morning, 6 total throughout the day. There was also a flash flood warning issued for Jacksonville itself, and you're about to see why that was. Many residents in Jacksonville managed to capture photos and videos of the flooding that occurred around Duval County that morning. All of the media I'm about to show you comes from the local News4Jax website, and a link will be in the description if you'd like to check out the whole collection. There were plenty of photos of roads being completely submerged, and even some pretty decent tree damage. Here you can see a large oak tree limb down on this person's lawn, with the majority of the limb thankfully landing away from the house. A few people managed to record full videos, which often included drivers driving through flooded roadways. I just want to say, please don't drive through flooded roadways. It's extremely dangerous, and you never know the true depth of the water until you're actually in it. Believe me, you don't want to end up like this car. Along with the water depth, small pieces of debris may be floating in the water, which can damage your car and especially your tires. It's always best to wait for floodwaters to recede, and it's just not worth risking your life and your property to save a few minutes on your drive. September 4th, 2024 was a fascinating case study for our region. It taught me more about the dynamics of nocturnal and early morning thunderstorms and how they can occur under the right circumstances. This day is also a fantastic look at how impactful flooding can be, even when there's a lack of other severe weather. Flooding events often get overlooked compared to the flashier forms of severe weather, so I'm glad I can highlight the impacts of flash flooding in this video, even if we didn't get to experience it directly to show y'all. Thank you for watching through this local case study. It contained easily some of the most photogenic lightning strikes we've ever captured, and I've been waiting to share the story for nearly a year now. I apologize for the lack of activity on this channel through much of 2025. I've been taking a lot of this time to learn more deeply about meteorology and the things that make the atmosphere tick, and I hope my progress is reflected well in this video. If you enjoyed what you saw here, or you learned something new, leave a like and subscribe if you haven't already. It helps our videos reach a wider audience, and the kind words and support really help motivate me to create these videos. It was actually a kind comment that helped spur me into making this video after not making one for so long, so genuinely thank you. But anyway, thank you again to everyone for watching, and we hope to see you in the next one.